Hello and welcome. Today I will talk about SAS text analytics, and our case focuses on finding safety risks in cars using text analytics. And our data is collected by NHTSA, which means National Highway Traffic and Safety Administration. And it's a US agency that collects complaints from citizens who have encountered some issue with their car and want to file a safety complaint. And one of these complaints might not be significant, but together they form a really valuable and interesting data set we can analyze. All right, let's get started. So first we will create a new project, and let's just give it a name. So NHTSA text analytics should be fine. And then we will select the project type. We could do also machine learning and forecasting projects here, but in this case we will do text analytics. And then we will select the table, and we will select an in-memory table that contains 5,000 rows of cases for this example. And for the project language, English is fine, but we will also support other languages in the system as well. It takes a second to create the project, and the only things we need to do in the data tab is select a text variable. And in our case, it's the complaint, which is a free text variable that contains the customer written text. And then we will select the component variable as a categorical variable, which will be used for some supervised learning. Then we can jump to the pipelines. And here you see the standard text analytics pipeline we have. In our case, we won't be needing the concepts and the sentiment node, so we can just delete those. Great, now we are left with the three nodes we need. So the text parsing takes care of the language understanding, and then the topics node is our main focus, and it does the unsupervised learning. And then the categories node does the supervised learning with the component variable we just selected. And the only thing we need to do is run the pipeline if we want to use the default settings. And in just a couple of seconds, it will analyze the text, run the couple of machine learning models and the text parsing on all the documents we have. After the pipeline is run, we can start checking the results. So let's open the text parsing node and check the results. As you can see, we have all the words that are contained in the documents here and their frequencies. We can check the raw data to see that how the words appear in them, and if everything looks okay. And as you can see, it's quite important that we have the language support so that all the different word inflections are matched to the root word. And in the right, we also have the stop list terms that are dropped from the analysis. So let's check also the categories results, and we have the component variable here we used for generating these rules. So a supervised learning algorithm analyzed the data and learned these certain words appear to be correlated with the component airbags. So it can combine the information that these certain words usually mean that the complaint is about airbags. And in the same way, with the suspension category, suspension, camber, and struts seem to be related to that category. So we can use those words for that type of categorization. But our main focus here is the unsupervised learning results. So we open that one. And the first topic that piques my interest is the lunging topic. And there seems to be 600 cases related to unexpected lunging, so the car moving forward on its own. And it might be a bit dangerous. And in the matched words, we can see the most important words that are used for the classification of the topic. And another topic that might be interesting is the power steering problem. So in the same way, there are certain keywords that are important for this classification of this topic that appear in these documents. And all of them describe the complaint in a bit different ways, but the vocabulary is the same, so the algorithm can understand that these are actually all speaking about the same topic. And I think we should investigate these results a bit further, so we can open up the output data we can get from this model. And let's just open the table so you can see that. And here we have every complaint we have in the data categorized for each of the topics and the relevancy values for the topics as well. And this is the data now we want to analyze further. So there is every complaint classified with all the topics. We are interested in two of those topics mainly, but all of them are contained in the dataset. And we can just save this as an in-memory table and jump straight to our visualization interface. We can use then to analyze this data further. And let's take the topic variables and convert those to categorical, as it's more suitable for our analysis. And let's start building our dashboard. So first we'll take the lunging topic and drag and drop that to the canvas. And it's just that simple. We just drag and drop different variables there and get visualizations from them. So let's use car make and the car model as well in our dashboard, and then we select also the year of the car. All right, now we have all the elements we need for the analysis. And next step would be to set up some interactions between the objects. So we set up some actions here between the objects, and then also some ranks. So we really don't need to see all the possible car makes and models. We just need to see the top 10 that are most frequent in this analysis. And as you see from the year histogram, there seems to be some extreme values there. So we want to filter those out so it looks a bit more sensible. Yeah, that looks much better. All right, I think we are quite ready for the analysis. And as we select now the 600 cases that seem to be related to the car lunging forward unexpectedly, we get quite interesting results here. So as you can see, majority of the cases related to Ford and freestyle from years 2005 to 2008. So that's quite particular car type that we were able to identify already. And if we want to do the same for the power steering problem, we can just duplicate the page and change one variable from the bar chart. So we change the lunging to the power steering, and replicate the analysis. And in this case, as you can see, Chevy Malibu is the top model here in this topic, and the years are from 2004 to 2009. And if you look at now the news related to these car types, it's quite clear that there are real recalls on those particular car types. So the launching problem and the power steering problem have been causing recalls in these car makes and models. All right, that's it. Hopefully that gave you a good idea how text analytics can be really useful. Thanks for watching.